changed this piece of bread so much it's unrecognizable? The answer is mold, a myriad of minute mushrooms. Entering the world of this plant is a fantastic experience. Mold appears to be a very unattractive, powdery mass. Actually, it lives by continually ramifying and changing itself. It multiplies with extraordinary speed, covering large surfaces in a few hours, and proliferating on the most unlikely substances. All mushrooms feed on organic substances and play an important role in the life of wooded areas where they exist. They rapidly convert fallen trees and leaves into nutritious substances that can be absorbed by the plant roots. Because of these and other characteristics, scientists before the 19th century placed mushrooms in the animal kingdom. If you've ever gone looking for mushrooms in woods outside the city, you'll know how difficult they are to find. In 10 days' time, a mushroom can grow and die, having completed its life cycle. In actual fact, we've been using the wrong term up to now. What we call mushrooms are nothing more than the fruit of the fungi plants. They live underground in a tangle of whitish filaments called a mycelium. The initial reproduction stage is caused by the germination of the spore or seed of the fungus. The spores look like very fine powder. They are so numerous because very few of them succeed in finding a place congenial to their germination. The spores produce elongated cells called hyphae, which become the mycelia. When the network of hyphae cannot expand any farther, it looks for a new way out above ground and produces the fruit-bearing body. Its function is to mature until it disperses its seeds. Pier Antonio Micheli, at the beginning of the 18th century, was the first scientist to note the importance of the fungus spores. Before him, in fact, fungi were not considered organisms capable of reproducing, but simple pathological degenerations of the humours of soil and plants. Several characteristics, such as poisonousness, stench, and edibleness, were discovered to be specializations, that is, important advantages which the individual species created to best exploit environmental conditions. Some mushrooms, for example, possess within them a range of different poisons, each of which acts differently on individual predators. This is the only way these plants can defend themselves from animals that would massacre them. The much sought-after Amanita caesarea, better known as the royal agaric, is often confused with its dangerous toadstool relative, the Amanita muscaria. If you're not careful, its poison can be very dangerous. It attacks the nervous system, causing tachycardia, dilation of the pupils, colored vision, hallucinations, raving, intoxication, and profound sleep. In the ancient Roman world, the mushroom was the symbol of death. The word fungus derives from funus ego, bearer of mourning. However, not all mushrooms publicize the fact that they are poisonous in such an obvious way. Some of them even lie camouflaged in the dense woods. Various species either conceal themselves or signal their presence to predators. Even the edible mushrooms hide themselves very well. But in this case, it's impossible not to notice them. At midnight, the Astræus hygrometricus begins to open. The fruit-bearing body containing the spores opens as a result of its extraordinary capacity to pick up the slightest trace of humidity in the air. The backward bending of the star-shaped fruit-bearing body enables it to detach itself from the mycelium. At dawn, like a vampire fleeing the heat of the sun, the star closes to protect its precious contents until the next night. Closing up also makes it possible to roll away from the spot where it was generated. In fields and meadows, we can easily tread on mushrooms like this. The puffballs, having reached maturity, literally explode. In this instant, this one is launching around 200 billion spores. Other spores have become specialized to the point where they can resist the gastric juices of animals and be normally eliminated and so dispersed. You shouldn't be surprised to meet these Coprinus comatae growing on dung. The different shapes of the fruit-bearing bodies imply different methods of producing the spores. The Clathrus cancellatus, with its reticular structure, has devised an infallible method for attracting insects. The sticky substance it emits from its fruit-bearing body gives off an odor of rotten meat that attracts the flies. When the insects land on it, they become covered with the spores. When they fly away, they take the spores with them. At the base of the broadleaf trunk grows the tiny Cyathus striatus. As soon as it matures, the thin membrane covering it breaks, revealing several minute sacs, the peridiolae containing the spores. Every once in a while, a drop of water falls into the little cup, and the peridiolae are forced out and thrown far away. They can survive for months in this condition. One day, they will open up and scatter their contents. Along will come a cow and eat the grass, and with it the spores. This way, a future full of mushrooms is assured. Fungi are plants that have adapted themselves to live their entire lives underground. However, this choice poses problems that are not easily solved. First of all, they can't achieve a chlorophyll synthesis. In order to resolve the problem, they have established a symbiotic relationship with the roots of other plants, to which they relinquish a series of mineral substances such as phosphorus and potassium, and receive in exchange the sugars necessary for their metabolism. In addition, the inability to reproduce underground has forced the fungi to bring their fruit-bearing body to the surface in order to scatter their spores as far as possible. Dispersing seeds, in order to assure future generations, is a problem for the entire vegetable kingdom, and each species was forced to devise its own individual strategy. Did you ever wake up in the morning to find your bathroom transformed into a jungle? It's not so improbable, and we'll show you why. Let's make an experiment. We take a box full of earth and place it in an oven at 200 degrees Celsius. That's the only way we can be sure of eliminating every trace of life. Then we'll leave our box of dirt sitting somewhere outside. While away the time, we'll take a trip into the woods. Here, we'll begin our exploration into the world of seeds. A wood, because of its luxuriant nature, has unlimited possibilities. Every plant is full of fruit. Every fruit is bursting with seeds. Every seed is capable of generating a new plant. In reality, germination isn't that simple because each seed is subjected to a severe selective ordeal. The common method plants employ to scatter their seeds is letting the fruit fall to the ground. In the conifer cones, the seeds fall before the fruit is fully mature. When the cone falls, a great number of pine seeds have already been scattered around the parent plant. Of these thousands of seeds, only those that move sufficiently far away will succeed in germinating. None of those lying under the umbrella of the parent tree will be able to grow. In addition, the resin contained in the needles and tree trunk slowly releases chemical substances that function as herbicides, preventing any other seeds from growing near the tree. The so-called asinine watermelon, instead, possesses a special mechanism to scatter its seeds a great distance. The oval fruit is full of a watery liquid. When mature, this liquid swells to such an extent that it expels the content of the fruit like a missile. Other plants have invented similar devices. Another name given to impatience, for example, noli me tangere, don't touch me, refers to the fact that its ripened capsules can burst at the slightest touch, spurting out the seeds. One of the reasons our planet is host to so many different kinds of plants is because the structure of their fruits facilitates the last stage of reproduction. The fruit of the common garden sorrel and that of the curious burdock are equipped with scores of small hooks, which allow it to attach itself to the fur of passing animals and transport the fruit as far away as possible. Some plants, during their evolution, cover their seeds with down to permit them to travel with the wind. Plants like the dandelion develop around the seed a minute parachute composed of filaments able to easily transport it up to 10 kilometers from the parent plant. In the spring, the air is filled with tiny balloons containing the germs of life. The trees take advantage of their height. The samaras of the maple tree are clothed in a thin membrane that can profit from the slightest breeze as it whirls through the air. All these methods of dissemination we've described also have their disadvantages. Their reliance on chance can be fatal for plant reproduction. In order to avoid this, the cyclamen adopts another method. As soon as it begins to wither, the long stem begins to coil around itself. In this way, it places all its seeds on the ground a few millimeters from each other. This small step strategy has the double advantage of reducing almost completely the possibility of failing to reproduce, and also protects each single seed. In open fields can be found a plant whose behavior is spectacularly dramatic. These seeds belong to the dodder plant. And twists in its desperate search for any kind of plant to use as a launching pad. Its principal objective, in fact, is to elongate itself as much as possible in order to take its seeds, housed in the tip of the plant, far from the spot where they were generated. Often, man is the chief vehicle for dispersing plant seeds. Some seeds, during the course of time, have become covered with a fleshy skin with an inviting aspect and tasty-looking pulp. The method works, even if the pulp turns out to be not so tasty. In these cases, the fruit is a beautiful and palatable confection elaborated by the plants to convince animals to disseminate them. So, why should we be amazed to see fig trees growing up the wall of a church? All these plants arrived way up here without any assistance from humans. At the end of our journey, we return to the abandoned box of dirt. It's now full of every type of plant. We counted 38 species of monocotyledons, 54 species of dicotyledons, and a fungus.